Iron ore went into one end of Ford's River Rouge Complex, and a finished automobile could roll out the other. That sounds like a slogan, but the Rouge, it was almost literal. Ships unloaded raw materials at Ford's own docks. Rail lines carried them through the site. Power plants fed the machines. Furnaces made steel. Glassworks turned sand into windshields. Tens of thousands of workers poured through the gates, enough people to rival a small city. Just listen to the world Ford built. This was not just a factory. It was an attempt to trap the entire industrial process inside one controlled system. And that was the problem. The more Ford brought under one roof, the more the Rouge became something no single company had ever truly managed before. A living industrial city, with all the power, pressure and chaos that came with it. So let us follow the raw materials through the Rouge and see what Henry Ford was really trying to build. Henry Ford did not arrive at the Rouge because he simply wanted a bigger factory. He arrived there because the Model T had taught him a painful lesson. Mass production was only as strong as the weakest supplier, the slowest railroad car, or the most expensive shipment standing in the way. By the 1910s, Ford was building cars at a pace the older industrial systems struggled to support. If a parts maker fell behind, Ford waited. If a railroad bottlenecked, Ford waited. If steel prices shifted, Ford paid. Every delay, every middleman, every outside dependency threatened the one promise that made Ford famous: a reliable car at a price ordinary people could afford. So Ford pushed toward a radical answer. Instead of buying everything from other companies, he wanted to control the steps himself. That idea is called vertical integration. In simple terms, it means owning or controlling multiple stages of production. A company does not just assemble the final product. It controls the materials, the parts, the transport, the power, and the finishing work that make the product possible. For most car companies, a factory was a place where parts came together. Engines, tyres, glass, steel and electrical components arrived from elsewhere, and workers assembled them into vehicles. Ford looked at that arrangement and saw waste hiding in every handoff. His dream was ore to automobile. That meant iron ore from Ford-controlled sources, carried by Ford ships, unloaded at Ford docks, moved on Ford rails, smelted in Ford furnaces, shaped in Ford mills, and eventually turned into a Ford car. Coal, limestone, rubber, wood, sand, and scrap metal all had a place in the same logic. The Rouge was designed less like a building and more like a private industrial ecosystem. This is why the site sprawled across thousands of acres instead of fitting neatly into a single plant. It needed blast furnaces, coke ovens, foundries, rolling mills, glass facilities, power generation, rail yards, docks, storage fields, assembly lines, and roads linking the whole machine together. Ford wanted speed, but he also wanted independence. If he could pull the supply chain inside his own gates, he could reduce uncertainty, cut costs, and make production obey his schedule. So what happened when raw material entered that private world? Ford found the land for this experiment in Dearborn, west of Detroit, along the River Rouge. Beginning around 1915, the company started acquiring property there, and in 1917 construction began on what would become one of the most ambitious industrial sites in the world. The location mattered. The river gave Ford a route for ships carrying raw materials. Nearby rail connections tied the site to mines, forests, markets, and the rest of the company. The land was flat, open, and large enough for Ford to stop thinking in terms of a factory block and start thinking in terms of an industrial map. By the time the Rouge reached its mature form, it covered roughly 2,000 acres. It eventually held dozens of major buildings and millions of square feet of industrial floor space. On a plan, it looked less like one plant and more like a city drawn for machines. Long sheds, furnace rows, storage yards, canals, rail spurs, conveyors, roads, and power lines all arranged around movement. To make that movement work, Ford needed architecture that could handle scale without slowing production down. That is where Albert Kahn became essential. Kahn was already famous for modern industrial design, and at the Rouge his work helped turn Ford's production logic into physical space. His buildings used wide spans, reinforced concrete, steel framing, large windows and open floor layouts that allowed machines, cranes, materials and workers to move with fewer interruptions. The structures were not decorative monuments, they were tools for flow. Major development continued through the 1920s and the complex kept adding specialised pieces. There were docks where ships could unload ore and coal. There were rail yards where cars could be sorted and routed. There were storage areas for raw materials, power facilities to feed the operation, and separate plants for processes like steel making, glass, foundry work and final assembly. The Rouge also had its own internal circulation system. Materials could arrive by water, shift to rail, move by conveyor, enter a furnace, pass into a mill and continue toward fabrication without leaving Ford's control. Every path was designed to reduce weighting. So when people called the Rouge a factory, they were using too small a word. It was a city built for one purpose, to turn raw material into finished automobiles at industrial speed. Before anything could become a Model A, it had to arrive as something far more basic: ore, coal, stone, sand, wood, rubber and oil. The Rouge began at the docks and rail yards where Ford pulled the outside world into its own industrial system. Great Lakes freighters came in heavy with iron ore from the upper lake regions. Other vessels and barges carried coal for fuel and coke, limestone for steel making and sand for glass. At the water's edge, cranes, unloaders, buckets, hoppers and conveyors turned cargo into movement. A ship did not simply dock and wait for men with shovels. Its load was swallowed by machinery and sent towards stockpiles, bins or the next process in the chain. Just listen to the kind of place this was before the machines inside even began their work. Then came the trains. Ford-controlled rail yards received cars loaded with lumber, rubber, copper, chemicals and supplies from points far beyond the river. Rail spurs branched through the complex like streets, letting cars be sorted, parked, emptied and redirected without depending on someone else's timetable. The Rouge did not just have access to transportation. Transportation was built into its body. The storage yards were just as important as the docks. The Great Lakes shipping season could be interrupted by winter ice, and a plant this large could not afford to starve because the water routes shut down. So the Rouge held enormous reserves, mountains of ore, piles of coal, stacks of limestone, and covered storage for materials that had to stay protected. Those stockpiles were not waste or clutter, they were a buffer against weather, delay, and market disruption. Feeding the Rouge was like feeding a city-sized organism. Every furnace, mill, glass line, foundry and assembly operation depended on a constant diet of raw material arriving in the right amount at the right time. If ore slowed down, steel would feel it. If coal ran short, power and heat would feel it. If sand, rubber or lumber missed its path, the interruption would travel forward until it reached the automobile itself. That is why logistics at the Rouge were not a side department hidden behind the real manufacturing. Logistics were the beginning of manufacturing. The river, the rails, the docks, the yards, the conveyors and the stockpiles formed the first stage of production, long before a worker handled a finished part. Inside the Rouge, coal did not go straight from a pile into a furnace. First, much of it had to be transformed into coke, the hard, porous fuel that made blast furnace iron making possible. Coke was made by heating coal in sealed ovens with little or no air. The goal was not to burn the coal away, but to drive off gases, oils and other volatile materials, leaving behind a carbon-rich solid strong enough to support the weight of a blast furnace charge. That strength mattered. Inside the furnace, layers of iron ore, coke and limestone were stacked high, and the coke had to hold open spaces for hot air and gases to move through. The byproducts were valuable too. Coke ovens produced gas and chemicals that could be captured and reused elsewhere in the industrial system. At the Rouge, even this dirty intermediate step fit the larger logic of integration. Squeeze usefulness out of every stage and keep the next operation supplied. Then came the blast furnaces, the towering engines that turned raw ore into molten iron. Iron ore entered with coke and limestone. Blasts of preheated air forced the coke to burn at extreme temperatures. The heat melted the iron, while chemical reactions pulled oxygen away from the ore. Limestone acted as a cleaning agent, combining with impurities to form slag, which could be drawn off separately. At the bottom of the furnace, molten iron collected like a glowing reservoir. It was tapped and sent onward while the slag was removed for other uses or disposal. This was not yet the refined steel of an automobile body or axle. It was pig iron, rich in carbon and impurities, but it was the essential foundation. From there, the Rouge moved into steelmaking. Molten iron could be carried to open hearth furnaces, where it was mixed with scrap and carefully refined. In those broad blazing furnaces, operators adjusted heat and chemistry to reduce unwanted elements and produce steel with the properties needed for different parts of a car. Frames, gears, springs, wheels, and body panels did not all ask the metal to do the same job, so the steel had to be controlled before it ever reached a rolling mill or press. This is where the scale of Ford's ambition becomes clear. The Rouge was not merely buying metal, shaping it, and bolting it into vehicles. It was taking coal and ore through coke ovens, blast furnaces, and steel furnaces, converting raw geology into the material base of mass production. Ford was not just assembling cars. He was manufacturing the metal they were made from. Once the steel was made, the Rouge still had to turn it into shapes a car could actually use. Some steel moved into rolling mills, where red-hot slabs and billets were squeezed between massive rollers again and again. Each pass reduced the thickness, lengthened the metal, and brought it closer to a usable form. Heavy sections could become bars or structural stock. Thinner material could be rolled into sheet steel, the flat starting point for doors, fenders, hoods, and other body panels. But sheet steel did not leave the Rouge to find its next purpose somewhere else. It moved deeper into the plant, towards stamping operations filled with giant presses and shaped dies. A flat blank of steel could be fed into a press, forced into a die under enormous pressure, and emerge as a curved panel with edges, ribs, holes, and contours. The automobile body, which looked smooth and almost simple from the outside, was really a collection of precisely formed metal pieces. The steel followed a heavier path. In foundries, molten metal was poured into molds to make castings for components that could not be stamped from sheet. Engine blocks, cylinder heads, and other rugged parts began as liquid metal filling carefully prepared cavities. Once cooled, the castings were knocked free, cleaned, and sent onward for finishing. The machine shops then brought these rough shapes into tolerance. Cutting tools bored cylinders, milled surfaces, drilled passages, and shaped parts so they could fit together with the accuracy an engine required. A casting was strong, but strength alone was not enough. The surfaces had to be flat, the holes had to line up, and moving parts needed clearances measured far more carefully than the eye could judge. What made the Rouge unusual was how much of this movement happened inside one industrial organism. Material crossed the complex on conveyors, rail tracks, cranes, and internal handling systems. Steel did not pass through a chain of separate companies, with each stage waiting on the last. It moved from furnace to mill, from mill to press, from foundry to machine shop, and finally toward assembly. This internal flow was the real machinery behind the famous assembly line. The visible line depended on a hidden river of metal parts arriving in the right sequence, in the right form, at the right time. And the Rouge did not stop with steel. Ford also tried to pull other major materials of the automobile into the same self-contained system, including materials that seem much farther from blast furnaces than anyone might expect. At the Rouge, even sand could be pulled into the logic of automobile production. Ford built glass operations that took raw materials, including sand, and turned them into the glass needed for cars. This was not just a side workshop making small parts. Automotive glass had to be melted, formed, cooled, cut, and finished to fit windshields, windows, and other openings with reliable dimensions. The car body could be stamped perfectly, but it still needed glass that matched the opening, sealed properly, and could move through assembly without becoming a bottleneck. That mattered because glass was a fragile link in the production chain. If an outside supplier could not deliver the right pieces at the right pace, finished cars could pile up, waiting for something as basic as a windshield. By bringing glassmaking closer to the rest of the process, Ford was trying to make even that dependency part of the Rouge's internal rhythm. Rubber pointed in the same direction. The automobile depended on rubber for tires, hoses, belts, seals, and countless small parts that made the machine usable instead of just movable. Ford pursued rubber processing and tyre-related facilities as part of the same drive to control more of the supply chain. The goal was not simply to own more buildings, it was to reduce the number of outside interruptions that could slow the assembly line. Then there was the powerhouse, one of the least glamorous but most important parts of the whole complex. The Rouge needed enormous amounts of electricity to drive machinery, lighting, cranes, conveyors, and machine tools. It also needed steam for heating, processing, and industrial power. The powerhouse helped supply those utilities on site, turning the Rouge into more than a collection of production departments. It became partly self-sustaining as its own industrial utility system. This changed what vertical integration meant. It was not limited to ore becoming steel or steel becoming parts. It included glass, rubber, electricity, steam, transport, handling, and timing. Ford was trying to pull the unstable outside world inside the fence line and make it obey the pace of the assembly line. But that solution created a new problem. The Rouge reduced dependence on outside suppliers by creating new dependencies inside the Rouge itself. If the glassworks stumbled, if rubber processing slowed, if the powerhouse failed, the whole industrial city could feel it. Ford had not eliminated dependence, he had concentrated it. The Rouge could not run on machinery alone. In the 1930s, more than 100,000 people worked inside Ford's industrial empire at the complex, and during the wartime surge, figures often climbed even higher, with peaks commonly cited around 120,000. That made the Rouge one of the largest concentrations of industrial labour in the world. Every day, workers poured through the gates in waves, arriving for shifts that fed the mills, foundries, glassworks, docks, engine plants, stamping operations, tool rooms, maintenance crews, and assembly lines. Some men handled molten metal, some operated presses, some drove cranes, repaired machines, loaded rail cars, checked parts, swept floors, or moved materials between departments. The scale was difficult to picture because the work was not gathered in one room. It was spread across a huge landscape of buildings, roads, tracks, conveyors, and yards. A worker might spend his entire day in one department and never see the ships unloading ore, the coke ovens burning, or the final assembly line moving cars toward completion. The Rouge was a city, but many of its citizens knew only their own industrial neighbourhood. Coordination depended on discipline. A late delivery inside the plant could matter as much as a late delivery from outside it. If one crew fell behind, another might wait. If a machine stopped, maintenance had to respond quickly. If a department missed its pace, the effect could travel through the system. The miracle was not just that the Rouge had so many operations under Ford control. The miracle was that people were expected to make those operations keep time with each other. That expectation came with pressure. Ford's system broke work into specialized tasks, measured output closely, and demanded attention to pace. The same integration that made the Rouge efficient also made it demanding. Workers were part of a vast production rhythm, and that rhythm did not easily slow down for fatigue, heat, noise, danger, or monotony. So the Rouge was never just a monument to engineering. It was also a human machine powered by thousands of bodies moving through gates, shifts, departments, and jobs that had to fit together almost perfectly. Ford had learned how to control raw materials, power, transport, and production. But controlling the Rouge also meant managing a workforce and an operation almost too large to comprehend. In 1940, Ford circulated a flowchart that turned the Rouge legend into a single astonishing claim. A complete automobile could be produced in about 28 hours. That line became the perfect symbol of what Henry Ford had tried to build. Not just a factory that assembled cars, but a controlled river of material. Ore came in by ship, coal became coke, iron became steel, steel became parts. Parts became engines, frames, bodies, axles, and finally finished cars rolling out of the plant. The Rouge promised to shrink a production chain that normally stretched across mines, mills, suppliers, railroads, warehouses, and distant factories into one coordinated industrial sequence. The 28-hour figure did not mean that one worker started with a rock and personally ended with a car the next day. It did not mean every atom in a specific Model A or later Ford vehicle could be traced through a simple stopwatch story from orbit to showroom. It meant that once the system was full, moving and synchronized, the time between raw material entering the flow and a finished automobile emerging could be compressed to a scale that seemed almost impossible. That was the miracle of the Rouge. Ford was not only saving money by owning more steps, he was saving time by removing the gaps between steps. Outside the Rouge, a delay could hide in a rail yard, a supplier's schedule, a warehouse, a port, or a contract negotiation. Inside the Rouge, those gaps became Ford's own problem to solve directly, and that was the hidden cost. To make the flow work, Ford needed more than blast furnaces and assembly lines. The company needed constant scheduling, inspection, maintenance, storage planning, traffic control, and energy management. A steel mill could not produce whatever it wanted whenever it wanted. It had to feed the stamping presses, the presses had to feed body construction, engine production had to match assembly demand, rail cars, conveyors, cranes, trucks and workers all had to arrive at the right place at the right time. The Rouge reduced dependence on outsiders, but it created dependence inside the system. If a critical machine failed, the problem did not stay local for long. If a department produced too much, material piled up. If it produced too little, downstream operations waited. If power, water, rail movement or maintenance fell behind, the scale that made the Rouge powerful could turn against it. So the 28-hour car was not a simple magic trick. It was the visible result of an enormous industrial balancing act. The Rouge showed how far vertical integration could go when a company tried to command the entire journey from raw material to finished product. Which raises the obvious question, if it was that impressive, why did modern car companies not simply copy the Rouge everywhere? Modern car companies did not abandon the Rouge because they forgot how impressive it was. They moved away from it because the automobile became too complex for one company to own every answer. In Ford's early mass production world, vertical integration made sense. If rubber, glass, steel, engines and parts could all be controlled by the same company, Ford could reduce uncertainty and push costs down through scale. But as vehicles gained automatic transmissions, electronics, safety systems, emissions controls, advanced plastics, sensors and software, each piece became its own technical universe. A specialized supplier could spend years improving one category of component and sell that knowledge to many automakers. That spread the cost of research across the industry instead of forcing one manufacturer to pay for every breakthrough alone. A company that made seats, fuel systems, brakes, or electronic modules could innovate deeply in that field, while the automaker focused on design, final assembly, brand, distribution, and overall vehicle engineering. The factory was no longer the whole empire, it became the center of a network. That network had risks, of course. A strike, a shipping delay, a chip shortage, or a supplier failure could still stop production. But owning every mine, mill, furnace, rail movement, and component operation carried its own risks, especially when technology changed quickly. The Rouge itself changed with that answer. Over time, much of the old industrial city was reduced, closed, sold, demolished, or repurposed. It did not remain the complete raw material to finished car machine of Ford mythology. Modern Rouge is smaller and more specialized, with operations such as the Dearborn truck plant assembling Ford F-Series trucks, rather than a single complex making nearly everything from the ground up. That is not a simple story of failure. It is a story about economics changing. The Rouge proved that vertical integration could reach a historic peak when scale, standardization, and control lined up. The fact that the model did not last forever shows that manufacturing complexity eventually became too large, too specialized, and too fast-moving for one industrial city to contain. River Rouge remains the clearest image of Ford's ambition. Ore unloaded from ships, coal feeding furnaces, rails carrying parts, workers moving through gates, and finished automobiles rolling out of one vast system. Ford gained extraordinary control by building extraordinary complexity. The factory became an industrial city, and that city showed both the power and the limits of vertical integration. If you want more industrial history stories like River Rouge, subscribe to the channel. Thank you for watching, and write a comment with the factory or industrial empire you want covered next.